Hey algebra students, here we are in chapter 5 looking at section 5.3 and we're going to talk about slope-intercept form. As we may or may not have talked about, now I can't remember, we've talked that there is something called standard form of a line, ax plus by equals c, where a, b, and c are all elements of the integers, blah, blah, blah. We talked about maybe this one as well, which is going to be the subject of our discussion today, slope-intercept form of a line. So the reason why it's called slope-intercept is because you see the slope right here, m, and the intercept, specifically, this is the y-intercept, is right here. So the slope-intercept form of a line refers to the slope of the line and the y-intercept being very present in the equation just as you see it here. All right, y is alone. Notice y has no coefficient aside from 1. It's on one side of the equation. The x term is first and then a constant term is next. The beautiful thing about this form and what makes it probably students' all-time favorite form of a linear equation is that you can see so much information from the equation just by looking at it. So again, the m value is the slope, the b value is the y-intercept, and you're able to graph pretty simply by going to the y-axis, putting a dot at b, because that is the y-intercept, the place where the graph intersects the y-axis or intercepts the y-axis, boom, and then you're able to kind of, the way we've done in a previous video or two, finagle your way through using the slope, and we're going to talk about that today. First example is pretty straightforward. It says write an equation given the slope and y-intercept. Well, remembering that y equals mx plus b is the slope-intercept form of a line, we're going to write an equation whose line has a slope of 3 and whose y-intercept is 5. Tells us exactly what to do. We're going to replace the m value with 3, which is our slope of this line that we're desiring to create, and our b value, we're going to replace it with 5 because that is the y-intercept. And by the way, we are done. So this is going to be a little bit more challenging. We're going to write an equation of a line given 2 points, and we're going to write an equation of the line shown in a graph. So let me get the graph up. Okay, so here's the graph, and we're going to write an equation of this line. They gave us 2 points. We've got the line. What to do? Well, here's the deal. We already have a preferred form. We've got y equals mx plus b. So we can find the equation of the line if we could have 2 things. If I knew what the slope was and if I knew what the y-intercept was, right? So looking at the points that we're given, we're kind of blessed because we are given the y-intercept. So that's a real coup for us. That's not always going to happen. So we need to really pay attention to chances or situations where we have 2 points and neither of them is the y-intercept. And it's not going to be too bad, but it's going to involve a little bit more work than this one. But fortunately for us, we've got the y-intercept. I'm going to cross that out. I've got y equals mx plus 3 because the y-intercept is 3. But now I've got to figure out what the slope is, and I don't know how to do that. But wait, I do. Remember back in the day, I would say something like, hey kids, slope is the change in y over the change in x, right? So it is. It's still the change in y over the change in x. And given 2 points, I can do that. So I'm simply going to do what I've been doing for a long time. I'm going to call this guy x sub 1, y sub 1, call this guy x sub 2, y sub 2, and follow the plan, right? And my plan is basically to say negative 1 minus 3, right? Change in y over change in x. 2 minus 0. Negative 1 minus 3 is a negative 4 over 2 minus 0, which is 2. My answer when I reduce this is going to be negative 2. So negative 2 refers to the slope, and I'm going to place that right there for the final answer of, drum roll please, negative 2x plus 3. I'm going to put a box around it because that's what we've been looking for. In this example, we're going to have the opportunity to demonstrate the true reason why everyone loves this form of an equation, slope-intercept form, and it's because it makes graphing really easy. So we're asked to graph this equation. Let's get an x and y axis. Okay, there we go. And what we'll do whenever you are given an equation in this form, you know where to begin. So I'm going to start off on the y-axis at the y-intercept where where the graph is to intercept the axis at 1. So I'm going to start off there, and I've taken care of that. The next thing I'm going to do is use the slope. The slope in this case is -2/3, or -2/3. I can write that as -2/3, or I could write it as 2/-3. All three of these mean exactly the same thing. The reason why I choose to write them differently is because it helps me navigate over the x and y plane, right? So what I can do is, if I'm using this one, I can say start here, go down 2, because the rise is negative, so I go down 1, 2, and my run is +3. 1, 2, 3, boom. And I can keep doing that. Down 2, 1, 2, run 1, 2, 3, boom. And you don't have to say boom if you don't want to. Okay, or I can use this one over here and rise 2 and go to the left 3. 1, 2, rise and go to the left 1, 2, 3. And instead of saying boom now, kids, I'm going to say bam. All right, and I can do it again and again for the rest of my life, and you'll see that I'll get this glorious line. This is why people absolutely adore this form of a linear equation, because it's so easy to graph. So after that decidedly wonderfully pleasurable experience of example 3, where we graphed an equation in slope-intercept form, now we're to graph an equation in standard form. How does it feel? Hopefully a little yucky. And so what I hope this makes us do is come up with a way to do this. So somebody's probably saying, I got to bring out my t-chart, x and y. And I'm saying, yeah, let's hold off on that for a second. Let's not do that. Let us put this equation, 5x minus 3y equals 6, into a form we like, the slope-intercept form, right? So remember, the slope-intercept form is y equals mx plus b. We need to isolate the y, move everything over to one side. So I'm going to do that. Let's get this over. Well, it is on that side. Well, let's get rid of this, right? So if I have -3y, and on both sides I'm going to add 5x, right? Then this goes away. I'm left with -3y is equal to 5x plus 6. I chose to put the 5x in front because I'm goaling for this form. And that, since I'm going for that form, I want to make sure I'm getting to that point, right? And the next thing I'm going to do to isolate y is I'm going to divide both sides by -3. When I divide the sum or difference of numbers by something else, I need to divide each of those terms by this number. And so this is -5/3 x minus 6 divided by 3 is a -2. All right, so this is the equation. These two equations are exactly the same. They are the same equation. They relate x and y exactly the same way. If it is true for these two, if you find an x and y that's true for this equation, it will also be true for this equation. I'm going to rewrite this really quickly, just because I thought it looked really bad. And let's go ahead and get started graphing. Now graphing's not too bad of a problem. So of course, as usual, I need my x and y axes. Okay, with that there, we're going to start graphing. So now that I know that my y-intercept is -2, I'm going to start down at -2. And my slope, I don't know if you guys were wondering about this, but I left my slope as an improper fraction because it really does help me. I didn't like write 1 2/3, -1 2/3, because that does not help me as much as this -5/3 will, because again, slope can be written, the slope here is -5/3, right? It can be written as -5 divided by 3 or as 5 divided by -3. And I'm going to use that to move around my, move around in graph. So here, if I use this one, it says go down 5, 1, 2, 3, 4, 5, and go to the right 3, 1, 2, 3. So I would expect a point to be somewhere here. And this one says go up 5, 1, 2, 3, 4, 5, and go back 3, 1, 2, 3. And you notice that these 3 points are collinear. It's not like when I went in the other direction, I had a point all the way out here. Every time I do this, once I'm using my slope correctly, I'm always going to get collinear points as I move Though that does not look like a line, I'm always going to have collinear points. Try again. I'm always going to have collinear points as long as I do that correctly. Ooh, today's a bad day. I'm going to do it without you guys seeing. Whew, there we go. So that's our linear equation. So let's just talk about what we did. We took an equation in standard form and we put it in y equals mx plus b form and slope-intercept form to make it easier for us to graph. We could have used an xy table and guessed and checked our way through, which is fine, but it's kind of a lot of work, and it is easier if we can use the forms that we have to our advantage. The next problem that we're going to work on deals with this fact, and it's the fact that in 1989, each person in the United States consumed an average of 133 pounds of natural sweeteners. And natural sweeteners in this case are considered to be any sweetener that is like sugar, honey, maple syrup, that sort of thing. All right, so we're going to write an equation in slope-intercept form for this first part. The natural sweeteners in foods, they've already told us what they are given by this information. So the amount of natural sweetener consumed has increased by an average of 2.6 pounds per year. Write a linear equation to find the average consumption of natural sweeteners in any year after 1989. So we know that the starting year that we're talking about, we had an average sugar intake of 133 pounds, and now it's going to increase at a rate of 2.6 per year. Now, I don't know if you remember, but rate of change is generally going to be our slope. Okay, so our slope is given here. And this, remember I said this is the year we're starting with. This is like where we start when we kind of make our graph. We start at the y-intercept, right? And so remember that our equation is for years after years after 1989. So the number, if I use like 1 for my year, that year would be 1990 because it will be how many years after 1989. So my equation is going to be, I'm going to use S, sugar consumption is equal to 2.6 times, let's say, X for the years, right? 2.6X plus 133. Because we're starting at 133, for every X years over 1989, that will be the sugar consumption for that year past 1989. Does that make sense? So in a way, 1999 is like our 0 year according to the variable that we're talking about. And if the S makes you uncomfortable, you're like, I just want Y. I was happy when it was Y. You can write it like this as well. Let's look at part B. So part B asks us to graph the equation. So the equation is y is equal to 2.6x plus 133. And our text recognize what we recognize is that the graph passes through 0, 0,133 and has a slope of 2.6. To be quite honest, I'm not about to graph this. I'm going to just use the answer from the textbook, and it's there. Voila. All right. They use C as the amount of consumption and N as the amount of as the number of years since 1989, and they came up with the same equation we did. And if we were to graph this, which I'm just not going to, you know why? Because a slope of 2.6 is a little bit hard and it would be like a lot, and then they did such a beautiful graph, so why not just use the graph that's in the textbook? So here it is, my friends. So we have the y-intercept here, and then this graph goes out here. They chose that point and maybe one other point, which is a nice way to get a graph as well. So instead of using the slope like 2.6 to kind of move up and down, you can just say, okay, let me use this point and another point. And they use an easy point because they said, well, if you put 10 in there, 2.6 times 10 is 26. Add that to 133, you get 159. So you got nice round numbers. But we're, like, as I said, this is a nice graph. Let's just use it. Okay, so find the number of pounds of natural sweeteners consumed by each person in 1999. And in 1999, we'd have to go here. We can plug a 9 in. We can either use our graph to kind of approximate, or we can plug in 9 into our equation, y equals 2.6 times 9 plus 133. And when we do that, we get 156.4 pounds of sugar per person. All right. Hopefully that made sense, my friends. I'm going to let you go. Thank you for hanging out with me. And let me know if there's anything that I can clear up, any questions that we can talk about. Email me, talk to me, text me. Let's do something. All right. Take care, guys. Bye-bye.